Well, you may remember some while ago I was showing you these small pilot drills which I'd ground years ago. I'd cylindrically ground these, and then I had to relieve the ODs so the drill wouldn't rub when I was drilling a hole. Now you can't back these off in the normal way. You've got to do it. It's a certain technique, and the way I do these, I've used this method years ago when I was employed in the tool room, and it creates almost a backing off as if it's been ground on a special machine or even milled. It's curved. You can't back these off with a normal wheel because you'll just get a series of backing off, and it wouldn't work. It just doesn't work. It's not practical. You can't do it. And the way it's done is what I hope to show. Now I bought some drills quite a while back now, and I thought they were a bargain, but actually they weren't really a bargain. There's virtually no relief on the back of the land, and what I plan to do is do this method which I've just described with this drill, and try and show the way it's done. It might be useful to anyone that wants to put more clearance on the twist drills. So hopefully we'll get set up and we'll have a go and show you how it's done. Now you can see there's virtually no clearance. It might look like there's clearance, but I assure you there isn't. I've tried drilling with these and they just rub.
Now this gives you an idea where the tooth rest is positioned. It's just behind the flute there, and when you traverse along with the drill, you've got to keep a constant pressure on the tooth rest. Now the wheel head is swiveled round at an angle, and the wheel is also dressed at an angle. I find this works best. I've never tried it with a straight wheel. It might work, I'm not really sure. I've always used this method. Now this wheel is not really suitable. I believe it's an 80 grit, and it really needs to be at 60. It needs something a little bit softer, and the tooth rest there, it needs to be hardened out so it's pot hard. The reason for that is that as you're traversing your drill or the pilot drill, it don't need to be it don't want to be digging in, and if it's not hard enough, it will dig in and spoil the job. The wheel head, as you can see, is swiveled round at an angle there, and that's just basically what I'm going to do. This sliding bush is not really suitable. I think I'm going to have problems with this. It's not ideal for doing this kind of a job I'm about to show. And there's the tooth rest there, and there's a more detailed view of it. As I say, it needs to be really hardened out, otherwise it'll dig in. Now I'm going to try and show how I relieve the area behind the land of the drill, and give it some more relief. Now there's virtually no clearance on this portion here, so I'm going to try and grind it away using the method I've been describing. I'm using this angled wheel. I've always used an angled wheel for backing off the rear of drills, and as you can see here, this is one I've done before, and you can see the relief there on this step drill, and this is what I'm going to try and show on this drill. It's a bit long really, is this for this machine. You probably could get away with using a straight wheel. I've never really tried it with a straight wheel. It would probably do the same thing, I'm not too sure really, but I've always used this wheel at an angle, and it gives me a little bit more clearance. You can see the relief there on the OD. It's almost, like a radial relief, and it looks quite good actually when they're done. The problem is I haven't really got the stroke, the length, which to cover the whole flute. But we'll see. We'll have a go. Now, for doing short pilots, it's perfect. Is this setup? I've done quite a few over the years, but it's the first time I've really attempted to have a go at a length like this. It's just a matter now of, like you can see there, on the rear of the land, just let the tooth rest follow the flute.
And there you can see virtually the shape of the clearance. It's virtually matching off the radius. If anything, it needs moving backwards slightly because it's taking more off the rear. So we'll just nudge it over. And also the wheel does actually need to come down slightly.
Also, please bear in mind that this is not a tutorial. It's just showing you the type of setup what I use to do this kind of work. There's a lot of trial and error and variations in this, but it just gives you some rough idea of what's involved. Ideally, you'd be better off with an air bearing type or linear ball sleeve. You can see it's starting to relieve at the front end here, but I'm actually struggling a little bit. It's because there's too much sticking out. Really, you really need to do short sections, like as if you're doing a pilot drill.
The work edge just needs to be tapped round slightly.
Now, to grind the flutes at this length or even longer, it really needs to be put between centres. A 60-degree pip needs to be ground on the front of the drill, and then put between centres. One end in a female centre and the other in the normal centre. And then the setup is different. The tooth guide is attached to the wheel head, and it's a lot more complicated setup than this way. Really, it's the better way. It's the more accurate and it's more rigid. But as I say, it's very complex, and it involves a lot of raising and lowering and quite a lot of trial and error actually. Whereas this is a lot simpler. But as I mentioned, you really do need a decent workhead, and this is not handling it well. I'm a bit disappointed really. I thought it might have done this length without too much trouble, but it really is struggling. It does the short sections like on the drills I've shown previously. It does them with no problem, but not for this length. And as I mentioned previously, this wheel is really a bit on the hard side, and it could do with being a 60, which unfortunately I don't have. Now, it's important to keep a constant pressure on the tooth rest and not let go. You don't want to be having it too tight, otherwise you'll not the bush won't travel forward with the drill. I'm having a little bit of a struggle, as I say, because this bush is not this bush and sleeve is not really very good. But keep constant pressure all the time, and it should grind okay. Well, as you can see, I haven't gone any longer on the flute. It just it's just not happy with it. But you can see what the result is, and it'll give you some idea of what you can do if you try this type of setup.
And there you can see the how it's backed off, and it's left a bit slightly smaller land than I would have liked. So we'll do the other flutes.
Now, the tool and gauge company I once worked for used to do this quite a lot on various drills sent in by customers, and some of the drills would be probably 1/2 inch or 3/4 inch diameter, even more, and they requested that the lands be thinned down to sometimes a 32nd, and the reason was, I believe, because it was specialised material they were drilling, and I think it were mostly plastics, and thinning down the lands just made the job so much easier. There were no binding and no melting of the plastic, and of course it gave a lot more clearance. Well, I'm afraid that were a bit of a washout, a bit of a disappointment there. I was hoping to get better results than this, but anyway, at least it does give you some idea what I were trying to achieve there, and at least you can see what was involved. Now, this tool and cutter grinder is a homemade affair, and it's not all that rigid really. I can't imagine anybody doing this sort of work now. That'd be all automatic. The profile would be ground with a specially formed wheel, and it just wouldn't happen. It's just an old kind of old-time method of relieving the drills, and I've never really seen any reference to this in any book or on the internet. I don't know anybody that's ever used this method. It might be just unique. If there's anybody out there that's used this method, it'd be interesting to know. Well, unfortunately, that was a bit of a disappointment, a bit of a disaster really, trying to do these drills, and it hadn't turned out how I planned. And unfortunately, it's the workhead, it's the bugbear. Now, when I did some pilot drills some years ago, I had a different workhead. It was a little bit different from the one I've got, and it was more rigid. And I used like Teflon bearings in it, Teflon sleeves, and it seemed to be okay. And I changed over to a hardened sleeve and hardened bush, and it doesn't seem to be as good. I really think I really need to change back to this old Teflon bushings what I use. The trouble with the Teflon, it picked up grit, and they didn't last very long. But I'll have to look into it again. But if you've got an air bearing or a linear ball type sleeve, you should be okay. Although ideally, as I say, they really do need to be done between centres, but that's a complete different setup, and doing them on a small workhead is a lot easier setup really. But it does give you some idea of what you can do and how you can modify drills. If you do make any step drills, you really do need to be able to relieve them properly. I suppose you can do them by hand, you can back it off by hand. I've done that in the past, and you can probably get away with it at a pinch by backing off like a slot drill or an end mill, but they won't look nice. But there again, if it does the job, who's bothered? But I always like to be able to do the step drills like the one on the bench there. I like to relieve them properly. Just personal preference really, but Now I'll make another pilot drill from scratch. I'll cylindrically grind the pilot and then relieve it as I've been describing. With it being a short pilot, it shouldn't pose any problems. And I'll also show a method I developed for backing off the actual step, the rear, the cutting edge. It's another technique I've never seen before, so that will be another video. Well, I hope you found this of interest, and once again thank you for watching.